Okay, once again, Mr. Lease here from Advanced Quantitative Reasoning. This is using Venn diagrams. We already went through this in class, but if you're absent or you just need to go ahead and brush up, you can go ahead and follow along right here and just watch this video. So we have this Venn diagram. Of course, there's some facts that we know right here. We have the total number of students taking Algebra 2, which is 18. You just take a look at the bubble right here, and that's 14 plus 4. That would be a total of 18. Total number of students taking chemistry, 5 plus 4, that would be, of course, 9. And students taking both chemistry and algebra 2 is 4. Taking neither would be 6. And if you're talking about the total number of students that are not in algebra 2, well, you'll take a look at the bubble. We have this. And then we have the fact that we're looking at the stuff outside of the bubble, which would be 6 and 5, which would be 11. And vice versa, students that are not taking chemistry, 6 plus 14 would be 20. So those are some of the facts. So if a student is selected at random from Mrs. Snow's homeroom, what is the probability that a student is taking Algebra 2 and chemistry? So we look right here in the center. I'm going to use my pencil because I don't want to go ahead and stain the paper with the pen yet. It would be 4 out of 29. Which, of course, if you were in the classroom, we got up to a whopping 20, I do believe, let's see, what was it again? 13.8. So this is 13.8%. Hopefully everyone sees that, 13.8. If a student selected at random from Mrs. Snow's homeroom has a probability, what is the probability is not taking Algebra 2 or chemistry? Of course, that's the students outside of this, so it would be 6 out of 29, which would give us 20.7%. And we're looking at the one right here. Find the probability of geometry or chemistry. So when I wrote this out inside of the classroom, I had to go ahead and take into account a few things. So P of Algebra 2 or P of algebra of chemistry. So that's what you would have for this. Now, the only thing about this, if you take a look at the Venn diagram, if I go ahead and take the total number of students that are taking Algebra 2, which would be 18 over 29, plus the total number of students taking chemistry would be 9 over 29, I count this center twice. And I don't want to do that, so I need to go ahead and remove the one instance of 4 from this. So I'm going to be subtracting the probability of Algebra 2 and Chem. I don't see it very well. Yeah, here we go. Now, that would mean we subtract 4 out of 29. Which gives us 23 over 29, which gives us a grand total of 79.3%. Okay, so that's how you do that for that particular one. So this is 79.3%. Now finally, we have find the probability the student is taking chemistry given that the student is not taking Algebra 2. Well, we have to look at the fact that the student is not taking Algebra 2. So this right here, all these students are taking Algebra 2. Now these students we wouldn't use. So we're looking at the students that are not taking Algebra 2, so we're only taking a look at these two numbers. Vice versa would work the same way. So we have a total of number of students that are not taking Algebra 2, 11. And 5 of those students are taking chemistry. Let me write it better. So this would be 45.5%. Okay, so that's how you find probabilities using the Venn diagram. But we also need to know how to go ahead and build our own Venn diagrams. So that's why we're going to look at this part right here. Student survey. Let me see. 758 spectators at a national tennis championship. The survey results indicate the following: 421 are male. 256 are have a two-handed backhand swing, and 176 of the people with the two-handed backhand swing are female. So let me go ahead and just do a couple number crunches because I'm curious. Actually, it's part of the work. 758 minus 421. That gives us the total number of females. Total number of females is 337 females. We have 256 have a two-handed backhand swing. Now, this right here means that they're both males and females. 176 of the people with the two-handed backhand swing are females. So, if you just subtract it, you'll find out the total number of males with the two-handed backhand swing. So that would be 80 males with a two-handed backhand swing. Now I'm going to go ahead and start building my Venn diagram. I'm going to use a new piece of paper. So I'm going to follow these pieces of instruction. So I'm going to start out with my actual Venn. Now I'm going to make two Venn diagrams, but they're going to still yield the same kind of data. I'm going to make a circle. Now right here it seems easier to go ahead and model the females rather than the males because of this right here, this fact. We have 176 of the people have a two-handed backhand swing. So we're going to make two circles. One is going to be for females. The other one is going to be those people that have a two-handed backhand swing. Because everyone outside of the female circle is going to be male. And with the 2H. Okay. So now, we look right here. This is what the two groups have in common, the 176. So 176 goes right in the middle. 80 goes right here because these are males with a two-handed backhand swing. Then we can go ahead and find out a few other pieces of information. There's 337 females. So if I take 176 minus 337, I'll just subtract these two numbers. That leaves me with 161 females without a two-handed backhand swing. Then finally we have the fact that we're looking at 421 males. So that's the total number of males, 80 of which have a two-handed backhand swing. So 80 minus 241. 341 males in this particular example have a two-handed backhand swing. Now we have to remember there's a total of 758, so we need to add all these numbers together to get that total. If we don't, we know we made a mistake. 161 plus 176 plus 80 plus 341. And that's a total of 758, as we can see. So right here we have this all, and then inside of class we'll go ahead and crunch these numbers. We'll look at all this stuff. We'll see you guys later.